Welcome to Mr. Baker's House of Knowledge.
That was entirely the worst. All right, so we're going to talk about points of concurrency today. To be concurrent is where three or more lines will cross in the same point. Three or more lines will share a point. There are a couple of special points of concurrency that occur within triangles that we're going to focus on. The first one is a concurrent point that happens from the perpendicular bisectors of each side of a triangle. And I'll show you this in a construction in just a second. But if I draw the perpendicular bisectors of each side of a triangle, they will all cross in the same point. And in fact, depending on what type of triangle it is, they can cross inside the triangle, they can cross outside the triangle, or they can actually cross on the hypotenuse of the triangle if they're a right triangle. Excuse me. So, perpendicular bisectors actually give us the point of concurrency that we call the circumcenter of the triangle. So, we're going to, over the course of the next couple of days, we're going to learn 4 different types of points of concurrency in a triangle, and each one of these is identified with a type of line, and you need to know what identifies with what. So perpendicular bisectors identify with something called the circumcenter. And by the way, this is on page 301 of your book, so you might want to go to your textbook, page 301 tonight, and start looking at some stuff out of the chapter, because they've got good pictures and good information, and it would probably do you good for every unit we do, just to peruse the chapter or the section that we're in, and look and see what the book has to say. Those I would expect A students to be able to do that. So, the circumcenter of a triangle means that if I put a compass point on that point that's the circumcenter, and I measure the distance between that and the corner of a triangle, and I draw a circle, all 3 corners will touch that circle. In other words, the distance from the point to the vertexes is the same. We refer to this as the circumcenter of the triangle. We refer to drawing the circle as a circle that is circumscribed about a triangle. Once again, there's a lot of vocabulary going on here. So we've got points of concurrency. Perpendicular bisectors will all cross at the same point of concurrency. And those perpendicular bisectors form the circumcenter. So perpendicular bisectors form the circumcenter. The circumcenter is basically the center of the polygon. Or if you drew a circle at the circumcenter, then that circle would touch all of the vertices of the triangle. It would be circumscribed about the polygon, the triangle. The other point of concurrency we're going to talk about is now, instead of doing the perpendicular bisectors, we're going to do the angle bisectors. If I look at all the different angle bisectors of a triangle, I will find another point of concurrency. That concurrency is the concurrency of the angle bisectors theorem, and it says that when you find that point is equidistant from the sides of the triangle. So if I were to draw a circle, at that point, the circle that I draw would be entirely inside the triangle or inscribed in the triangle. So the angle bisectors make a point of concurrency known as the incenter. So we have perpendicular bisectors that find a triangle's circumcenter, and we have angle bisectors that find a triangle's incenter. You might want to write that down because those 2 connections are very important, especially if we expand our knowledge. All right, so what does this all mean? Well, here I created a right triangle, and I went ahead and I constructed the perpendicular bisectors of each of the sides of the right triangle. And it's interesting, for this right triangle, when I constructed all the perpendicular bisectors, I came up with a circumcenter that actually crossed on the hypotenuse of that right triangle. So it's important to note that this was from a right triangle. So there are different places that you will find circumcenters. In an acute triangle where all the angles are less than 90, the circumcenter will always be inside the triangle. In an obtuse triangle where one of the angles is greater than 90, the circumcenter will be found outside the triangle. And if we have time, I'll do a construction at the end of the period and show you that. And then on a right triangle, the circumcenter will always be found at the midpoint of the hypotenuse. This is important because later we're going to be doing some problems where I give you actually right triangles on the coordinate plane, and you're going to have to tell me the coordinate of the circumcenter. You're going to have to know that what you need to do there is find the midpoint of the hypotenuse. So the only way you can find the coordinate of the circumcenter with the stuff that I'm giving you tonight is by knowing you have the triangle that's a right triangle, knowing which side is the hypotenuse and being able to find the midpoint of that hypotenuse. Goodness gracious, I apologize for the coughing. So you might want to write this stuff down. Acute angle, circumcenter is inside. Right triangles is the midpoint of the hypotenuse, and obtuse triangles, circumcenter is on the outside. All right, so let's do a problem in which I'm going to apply that set of knowledge. So what are the coordinates of the circumcenter of a triangle with vertices 0, 6, 0, 0, and 4, 0? So what I'm going to do first is I better be working with a right triangle for this to work. So I think what I'm going to do is I'm going to make a sketch of these points. So I notice that they're all positive numbers when I have numbers. So I'm just going to make this my 0, 0 point. So that's point O. And then point P was 0, 6, 1, 2, 3, 4, 5, 6. Here's point P, and then point S is 4, 0. So 1, 2, 3, 4, 0. And here I have a right triangle. Pretty atrociously drawn, but you get the idea. Really, the only thing I'm trying to decide from looking at this figure is this a right triangle? And I think it is. And what would be the hypotenuse of this right triangle? PS. So I want to find the midpoint of PS. Because I remember from the notes that I took in class that the circumcenter on a right triangle is the midpoint of the hypotenuse. So if the hypotenuse is PS, then the midpoint of PS will find my circumcenter for me. And so basically, if I do the midpoint of the x-coordinate, so the x-coordinate of P is 0, and the x-coordinate of S is 4, and I divide that by 2, that's going to give me 4 divided by 2, or 2. And my, the y-coordinate of P is 6, and the y-coordinate of S is 0, and that's going to give me 6 divided by 2, which is 3. So the midpoint of PS is 2, 3. So basically, if I go over 2 and up 3, I should be on the circumcenter of the triangle, and in which case, I ought to be able to take my compass, and remember, this is a sketch here. Whoa. But that was pretty close that I got all the corners of the triangle for my pretty inaccurate sketch. Well, I sketched it out, and to be able to do these problems, I'm going to go ahead and tell you, all of the ones that you get tonight are right triangles. But I mean, you could compare the slope of line PO with the slope of line OS. The slope of line PO is undefined. The slope of line OS is 0, and undefined and zero-sloped lines are perpendicular, so you know it's a right triangle. If they weren't horizontal and vertical lines, then you could compare their slopes, multiply them together. If you got -1, they would be perpendicular. So mathematically, you could go ahead and make an argument that even if you're just doing a sketch, these two lines are perpendicular by performing that algorithm. Yes, ma'am?
How do you know which points to use for the X and Y?
You have to use the endpoints of the hypotenuse to find the circumcenter. That's why we identified PS as the hypotenuse, so that we were finding the midpoint of PS. So we used P and we used S, because PS was the hypotenuse. Does that make sense? Good. I want you guys to give it a shot now. I want you to go ahead and find the coordinates of the circumcenter of the triangle with those three vertices. So you might want to intelligently draw your X and Y axis, sketch it out, see if you can't figure out which side is the hypotenuse of the right triangle, and then find the midpoint of the hypotenuse. All right, so once again, I want to find the circumcenter. I know that the circumcenter is the midpoint of the hypotenuse of a right triangle. I notice that all of my numbers are mostly positive, so I'm going to make a coordinate 1 really big area for my sketch. I'm going to graph point A, which is 2, 7. That's that point right there. And then B is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7. So here's A, here's B, and C is 10, 3. So I think it's pretty obvious that the hypotenuse is which line segment? AC. So I want to find the midpoint of AC, because the midpoint of AC is going to be my circumcenter, because it's the hypotenuse of the right triangle. All right, so to find the midpoint of AC, I need to find the MX, so that'll be 2 plus 10 divided by 2, which is 12 divided by 2, which is 6, and I need to find the MY, which is 7 plus 3 divided by 2, or 10 divided by 2, which is 5. So the midpoint of AC, or my circumcenter, is 6, 5. So mathematically, if you have a coordinate plane, you could find the point that was the circumcenter of a triangle. In a more practical sense, what you can... In a practical sense, what you can also do is you can find things geometrically that, like if you were a city planner and you wanted to plan your city out. So I've got an elementary school, a high school, and middle school, and I want to make sure that when I build the city, that the local fire station is as close as possible to all three schools. So I want it to be the same distance away from all the schools. So if you looked at this right here as a triangle, and you went and you computed the perpendicular bisectors of each side of the triangle, you could find the point of concurrency, and then you would know where to build your fire station. So if you get a problem like this on homework, and you have to do something like this on the homework, and the town planner wants to place a bench equidistant from the three trees in the park, where should he put the bench? Just go ahead and fill in the triangle, and then just kind of do your best sketch of what you think the perpendicular bisector would be of each one, and just show me that they're perpendicular lines, and mark your point of concurrency and say, put the bench here. Just show me that you understand the concept that the perpendicular bisectors are going to be a point of concurrency. Now, does that actually make these equidistant from all of these points? Yes, because the point of concurrency for these is equidistant from the vertex. And then finally, we can see an algebraic connection when we start doing this stuff. So we're going to identify and use the incenter of a triangle. So point G is an incenter. An incenter is found by where all of the angle bisectors cross. And we know the incenter makes all of these lines congruent to each other. That means that GE is equal to GF, which is also equal to GD. Well, we've got an equation we can now set up. Knowing that GE and GF are equal to each other, we can create an equation. And remember, I said that geometry, part of it is knowing how to fill in the equation. So once you know that this is true, you could just substitute stuff in, and now do I have an algebraic ability to solve for x? How would I do that? Subtract x from both sides, so that'll give me x minus 7 equal 4. Then what would I do? Add 7 to both sides, and x is equal to 11. And now that I know that x is equal to 11, I can find any one of these. So if I wanted to find GF, GF would equal x plus 11, or I'm sorry, x plus 4. And we know x is 11, and we know 11 plus 4 is 15. So GF is equal to 15. So if I know GF is equal to 15, don't I also know that GE is equal to 15? And don't I also know that GD is equal to 15? And that was my solution. What's the value of GD? GD is equal to 15. So how did I come to the conclusion that all three of those were the same? I came to the conclusion that all three of those were the same because this was the incenter found by all of the bisected angles crossing, the lines that bisect the angles crossing, giving me a point of concurrency that's the incenter that's equidistant from each side of the triangle. So knowing that information, you should be able to do something like this. And notice in this one I only gave you 2 bisecting angles. How many bisecting angles do you need? Well, it doesn't matter. The third bisecting angle will cross the same place that the other 2 bisecting angles did. Otherwise, it wouldn't be a point of concurrency. So 2 lines is enough to find your point of crossing, your point of concurrency. You don't need to find all 3. So what would we do to set this one up? What can I say about OQ, MQ, and NQ? Why? Yep, because Q is the incenter. So QN is equal to QM, which makes 5x plus 36 equal to 2x plus 51. And so we'll subtract 2x from both sides. Then we'll subtract 36 from both sides. So that leaves us with 15. So x is equal to 5. So if I go back and plug it in, what's 5 times 5?
25.
And what's 25 plus 36?
41. I don't think it's anyone.
Okay. 25 plus 36 is equal to 61. So, would it be possible for QP to be 50? Why not? Why is it not possible? Is QP the distance from Q to this line? It is. Now remember, distance are perpendicular, so QN can't be the distance and QP be the distance too. So the answer is QP is not congruent to these others, so QP doesn't have to be 61, but could QP be 50? So you could have a triangle in which this side, which was one of the legs of the triangle, was 61, and the hypotenuse was 50? Think about it. The answer is no, because the hypotenuse is always going to be bigger than the leg. The hypotenuse is the longest side of the triangle. So the smallest this could be has to be greater than 61, no matter how you draw the rest of the triangle. All right, so your homework tonight is on the pacing guide that I put up, and let's take a look at this week.